Alright, in this video I'm going to go over the review of 3.1 for exam 3. So first of all, we're supposed to graph this quadratic function, so we're expecting a parabola. First thing we need to do is find the vertex. So we're going to use the vertex formula, which is negative b over 2a. So here b is 6, so it'll be negative 6 over 2 times a, and a is negative 1. And so we're going to end up with 3 here. 6 over negative 2 is 3. So then to find the y value of the vertex, we'll plug 3 into the function. And when you do that, you get negative 9 plus 18 minus 5, which is going to be 4. So the vertex is the point 3, 4, and that means our axis of symmetry is x equals 3. It's always x equals whatever the x value of the vertex is. And so let's go ahead and plot this point and our vertex, and x equals 3. So at this point we really know pretty much what the graph's going to look like. We know this graph's going to open down because we have a negative 1x squared. Our leading coefficient is negative. So it does open down, which so we have a good idea of what it's going to look like. We just need to find a few points. So let's go ahead and find the x-intercept, or intercepts depending on the situation. So when we let y equals 0, we get 0 equals negative x squared plus 6x minus 5. And I really don't like the minus x squared, so we can actually multiply both sides by negative 1. And that's just going to change the signs on the right side, and negative 1 times 0 doesn't change the left side. So we can factor this. The numbers that are going to work are negative 1 and negative 5. And I can take the shortcut here because this is a 1x squared, so it'll be x minus 1 and x minus 5. Which means our two solutions are 1 and 5. So we have two x-intercepts, which from the picture that's not surprising. And so 1, 0 and 5, 0 are going to be on the graph. Let's go ahead and put those in. So we got 3 points, we've got to find 2 more. Let's find the y-intercept. That's the easiest point, because if we replace x with 0, which is how we find a y-intercept, we're going to get negative 5. So let's go ahead and put that point on the graph, and using symmetry we have the point on the other side of the axis of symmetry. That's 3 away on the other side, and so there's our graph. And we do have 5 points. So let's go ahead and move on. Oh, I'm sorry, we have a minimum here because actually that's not the case. We actually have a maximum here. As you can see from the picture, and our maximum is going to be 4, the y value of the vertex. Alright, let's move on to the next problem. So I'll also do this one here. This function, quadratic functions, written in the vertex form, which means it's easy to find the vertex. I'm going to go ahead and write the vertex form right above. So you can see here a is 1, and h is going to be 2, and k is going to be negative 5. And so our vertex is hk, which would be 2, negative 5. The x value is always the opposite if you look at what's inside the parentheses here. And then the k value is just the same sign as what you see right there. So the point 2, negative 5 is our vertex, which means our axis of symmetry is x equals 2. So let's go ahead and plot our vertex, and let's draw the axis of symmetry through the vertex. And this one's going to open up because notice we've got a 1 out front. At the very front we don't have a number there, it's understood to be 1. And it is positive, so we're going to open up. And we're certainly going to have a minimum here. And it's going to be the y value of the vertex, which is negative 5. And we need to find a few points here. So let's go ahead and find the y-intercept. So we'll let x be 0. When you do that, you're going to get negative 2 squared minus 5, which is 4 minus 5, or negative 1. So let's go ahead and put that on the graph, which means we've got another point on the other side using symmetry. Now you could find the x-intercept or intercepts, but it's a little bit of work if we put 0 on the left side in for f of x or y. So let's just go ahead and, if you look at the graph, it would be nice to know our point when x is 1, and 1's a pretty easy number to work with, so let's use 1 and just plug that into the function. We get 1 minus 2 squared, that's negative 1 squared minus 5, so it'll be 1 minus 5, which is negative 4. So let's go ahead and put that in, and of course we can use symmetry to get another point. And so there's our graph. All right, let's move on to the next problem here. For these problems, it says find the maximum or minimum value of each function. And these are all quadratic functions, so their graphs are parabolas. And we know the maximum or the minimum is just going to be the y value of the vertex. So with these kinds of problems, you have to find the vertex. So you're going to need the vertex formula. I'm going to go ahead and do A and C. So here you're going to get negative 12 over 2 times 2. And so we're going to end up getting 3. And then that's just the x value of the vertex. Then you'll plug that into the function to get the y value of the vertex. You'll get 2 times 9 minus 36 plus 1. And we're going to end up getting negative 17 here. Now because of the 2, this parabola opens up, which means we're going to have a minimum at the bottom there. So negative 17 is our minimum value. So in each of these problems, you would want to find the vertex. In part C, it's in that vertex formula, or vertex form. And so in this problem, our vertex, we'll see h is going to be negative 3 and k is going to be 7. So the vertex is negative 3, 7. And this thing certainly opens down because of that negative 2, which means we're going to have a maximum, and it's going to be 7. Again, the maximum or minimum is always the y value of the vertex. So when you get to 4 and 5 on these problems, these are just word problems where you have a quadratic function, you're looking for a minimum or a maximum, and you're going to find it at the vertex. So the main thing is you want to read these carefully and make sure you know what your variables represent. So on number 4, it says a manufacturer of water pumps has gathered data suggesting the cost in dollars of producing T units per hour of a new style pump will be. So basically these units are pumps, water pumps, and C of T is the cost of producing T water pumps. So it says how many pumps per hour will minimize the cost. So usually we use x equals negative b over 2a to find the vertex. And by the way, this is a parabola that opens up, so we would expect to find a minimum here. Let's go ahead and instead of x, we'll use t here. Oops, I'm getting caught up here. So t equals negative b over 2a. If you put x, it would not be a problem, but keep in mind here your input is really t. And so here you're going to get negative 22 over 2 times 1. You're going to get 11 here. And that's the number of water pumps. And it does ask us here how many water pumps or how many pumps per hour will minimize the cost, and that'd be 11. And to actually find the minimum cost, we plug the 11 into the function. And you do get 45 here, so it's going to be $45. So number 5 is pretty similar to this one. Number 6, I told you guys not to worry about it. I'm not going to put anything like that on the test. So that's going to be the end of this video. The other part will be in a separate video.